Across the vast farmlands that feed hundreds of millions, one machine stands out as the irreplaceable cornerstone of modern agriculture: the tractor. It tills the soil, plants the seeds, and harvests the fruits of labor, forming the very foundation of modern agriculture. For the past 3 decades, one man has been at the very heart of the development of tractors in China. His name is Xue Zhifei. The engineer hasn't just watched the tractor revolution unfold. He has been its primary driver, steering it from the simple mechanics of the past to the intelligent digital future. In October 2016, China's first unmanned tractor was unveiled. In addition to functions such as steering, braking, and calculating optimal routes, it can also achieve automatic control of agricultural implements and calculate operational processes through intelligent control technology. In other words, the tractor works much like a wheeled mobile robot in the fields. This unmanned tractor was developed by Xue Zhifei and his colleagues. So, how was the unmanned tractor born? What challenges did Xue Zhifei and his team encounter during the research and development process? Xue Zhifei was born in 1972 in a rural area of Shanxi province in northern China. As a child, he was drawn to the tractors working in the fields when he helped his parents with farm work. The convenience and efficiency the tractors brought to farms left a deep impression on him.
When I was a child, the tractors we saw in our village were primarily used for plowing, and their efficiency was far higher than that of cattle. Back then, when we used cattle for plowing with a small plowshare, we might only plow a plot of land in half a day. But when a tractor with a plow passed by, it could cover a large area in minutes. The efficiency of the tractor was significantly higher than that of cattle. So when I took the National College entrance exams, I hoped to pursue a career in this direction.
In the early 1990s, Xue Zhifei achieved his goal and went to northeast China to attend Jilin University of Technology, majoring in tractor engineering. In July 1996, at the age of 24, he graduated and subsequently joined the YTO Group Corporation, which was headquartered in central China's Henan province. From the moment he joined the company, Xue Zhifei was determined to research and develop more advanced, domestically produced tractors. In 1997, he became involved in the research and development of high-horsepower tractors. At that time, tractors under 80 horsepower were defined as small and medium horsepower, while those with 80 to 200 horsepower were classified as high horsepower ones. Back then, the small four-wheel tractors produced by the YTO Group were widely used in China's rural areas. However, with economic development and increased productivity, agricultural production demanded more high-horsepower tractors. The task of developing this kind of tractor fell to Xue Zhifei and his colleagues, a team of 12 members. With insufficient research and development experience, developing a high-horsepower tractor was a tremendous challenge for them.
In state-owned farms, the land area is very vast. Back then, relying on small four-wheel tractors meant low operational efficiency. So our country needed large tractors. But at that time, we didn't have domestically produced large tractors. Therefore, we had a firm belief that we absolutely had to develop our own domestic large tractors. The process of going from nothing to something is very difficult. It's not just about the development of a single product's technology. It's actually connected to the development of the entire nation's industrial foundation. The blueprints and technical documents we used were from abroad, so we had to analyze them, match them with our own situation, and then determine what we could do next.
Based on absorbing and assimilating foreign technology, Xue Zhifei and his colleagues designed and produced a batch of components and assembled them into a final product. But high horsepower tractors have extremely high precision requirements for the machining of components. Even a simple gear must achieve a so-called grade 6 precision, which means errors have to be controlled to within tens of micrometers. At that time, however, domestic machining technology was not very advanced and could only achieve much lower precision. This resulted in the tractors they assembled being unstable in quality. So the tractors of this type the company sold were often returned by customers.
In 1997, there was a large-scale return of vehicles. We had to deal with the situation urgently. All returned tractors needed to have their causes investigated and identified. We discovered that these parts had been assembled without meeting our design requirements, which ultimately led to the low quality of the final products.
Xue Zhifei and his team came up with a solution. They screened components of varying precision and selected those high-precision ones that met the design requirements. They then assembled a batch of finished high-horsepower tractors, thereby meeting the design specifications. But then, new problems arose. Although the product's performance met the design requirements, the high production cost made the price of domestically produced high-horsepower tractors prohibitive for ordinary farmers.
For example, if I produce 10 gears but only 2 meet the standards, the cost of producing all 10 gears has to be absorbed by those 2 qualified ones. This makes the cost of the final product too high.
However, promoting the indigenous production of large tractors was imperative. Xue Zhifei and his colleagues had to find new solutions. They embarked on a new round of research and development. After several years of repeated testing and debugging, the high-horsepower four-wheel tractor they developed was officially launched on the market in 2000. This tractor could handle basic farming operations and was affordable, making it popular in the market. On the path of innovation, Xue Zhifei is unrelenting. In 2009, he led a team to begin research and development on a power shift tractor. Power shift technology is a crucial component in the automation of tractor development. It allows gear changes without depressing the clutch. Simply pressing a button completes the shift. During this process, power delivery remains uninterrupted, thereby improving the tractor's operational efficiency and driving comfort.
When a tractor is working in the field, its load is quite heavy. If you need to shift gears, traditionally, you have to depress the clutch to cut the power, allowing the gears to synchronize. However, under such a heavy load during synchronization, the tractor can come to a stop. With a power shift, the power is not cut during the gear change. The biggest advantage for the user is the ability to work continuously without stopping, which essentially means the tractor's work efficiency is improved.
Under Xue Zhifei's leadership, the R&D team began by designing the tractor's exterior and gradually completed the design of its various internal systems. But one of the critical technologies for a power shift tractor is the design of the transmission system. To ensure that power is not interrupted during gear shifts, the core component of the transmission, the wet clutch, must be able to withstand high torque loads. This required the wet clutch to be welded with exceptional strength. Through repeated exploration and experiments, Xue Zhifei and his team successfully completed the welding of the wet clutch, achieving a successful design for a domestically produced power shift transmission system. In September 2010, Xue Zhifei's team produced a prototype and prepared to conduct field tests. However, just a few months later, their company acquired a foreign factory capable of producing mature power shift transmission systems. The company's leadership thus decided to integrate this acquired power shift transmission technology with the tractor designed by Xue Zhifei's team.
因为当时我们在整个生产加工工艺这块已经开始准备了。
At that time, we had already begun preparations for the mass production of the tractor we developed, but we were asked to hold. This did affect me somewhat. I felt it was a bit of a pity. Our own design was 200 horsepower. After our company acquired the foreign factory, we had to redefine the whole machine based on the capabilities of that company's transmission system. So we needed to develop a tractor with 220 horsepower, an increase of 20 horsepower over our original design. This change required a tremendous amount of work. We had to redefine everything and made technical adjustments to various components. Our goal of design was to benchmark against the most advanced international products of that time and achieve a world-leading level.
Redefining the whole machine was no simple task. The tractor's engine not only provides power for mobility, but also powers functions like the exhaust, implements, and hydraulics. All these must be accounted for within the engine's output. Xue Zhifei's colleague, Yang Yanpeng, explains that this was a real challenge.
它有220马力的潜能，但是你只用到200马力，对用户来说是一种浪费。
It has a potential of 220 horsepower, but if you can only use 200 horsepower, that's a waste for the user. From a functional perspective, we had to redefine the whole tractor to give it better adaptability. For example, when we are plowing, the tractor's overall temperature must not get too high. We need to ensure that the heat generated by the tractor itself can be dissipated by its own cooling system. This allows the entire tractor to maintain a relatively balanced temperature. Furthermore, the lubrication system, variable displacement pumps, hydraulic system and lift system all need to be recalculated and rematched.
Xue Zhifei and his team conducted rounds of research both in the workshop and out in the fields, validating the most accurate results through practical fieldwork. In 2014, the first model, the Dongfang Hong LF2204 power shift tractor, was launched on the domestic market. This product broke the monopoly that foreign companies had held in China's high-end agricultural machinery market. It forced the price of a brand of foreign power shift tractors to drop by around 400,000 yuan, or about $60,000 per unit. No sooner did Xue Zhifei make such a breakthrough than he was assigned a new task. At the time, the development of a key national project, the 400 horsepower continuously variable transmission, or CVT tractor, had reached a critical juncture. Xue Zhifei once again took on this significant challenge. In the process of solving a technical bottleneck, he decided to pursue a bold innovation. So, what exactly was this innovation?
无级变速的优点，它就是能够在达到一定的速度以后。
The advantage of a CVT is that once a certain speed is reached, the tractor's speed can change automatically without requiring the operator to shift gears. Of course, we initially hoped to receive support from a foreign team. However, at that time, the foreign company quoted us a fee of 100 million yuan just to develop the control system. We absolutely could not afford that cost. That left us with no choice but to explore and figure it out ourselves. I later told our R&D team, we must grit our teeth and find our own way.
The first critical challenge they needed to overcome was how to enable the system to shift gear based on the vehicle's speed. His colleague Xue Zhifei recalls what challenges they have met in the R&D process.
When we started this R&D project, the technical documentation we could access was very limited. We first had to understand what CVT technology actually entailed. We realized that to design a transmission system capable of range shifting, sensors were absolutely essential. It could not be done without their perception. Moreover, a single sensor wasn't enough. Multiple sensors were required. The sensors needed to perceive speed, specifically both the engine speed and the rotational speed of the clutch gears had to be detected. The sensors would calculate these speeds, and based on that calculation, the system would determine the precise point where a shift was needed, allowing the clutch to engage the new range.
After countless tests and trials, Xue Zhifei's team completed the system design and produced a prototype. But he discovered that although the prototype could achieve automatic shifting, it was very unstable, leading to low operational efficiency.
During operation, the tractor needs to remain in a high-efficiency state, but the hydraulic section cannot work continuously. It only engages during the gear shift process. For example, if I set the first range for speeds from 0 to 8 km per hour and the second range for 6 to 12 km per hour, then shifting might occur within the overlapping 6 to 8 km per hour range. This causes the hydraulic system to engage repeatedly, leading to frequent gear shifting back and forth, which reduces overall efficiency.
To solve the efficiency problem of the hydraulic system in the CVT tractor, Xue Zhifei led the technical team in conducting additional research. They ultimately concluded that it was necessary to ensure that the clutches for both ranges were connected to the engine at the moment of shifting. In 2016, the codenamed Dongfang Hong LW4004 tractor made its public debut, marking the successful development of China's first domestically produced 400 horsepower CVT tractor. This achievement broke the foreign monopoly in this field and enabled China to independently master the key core technologies of CVT tractors. Building on what they have achieved, Xue Zhifei and his colleagues later developed China's first unmanned tractor, which is capable of remote start, direction control, obstacle avoidance, and 24-hour all-weather automatic identification. The tractor has a straight line driving error of no more than 2.5 centimeters over 100 meters, an improvement in precision by 13 times compared to the earliest crawler tractor. Thus, it is renowned as the China precision of the agricultural machinery industry. More importantly, this level of precision has reached world-class standards, demonstrating that China's research, development and manufacturing of unmanned tractors are now in sync with internationally advanced levels. Due to his outstanding contributions in the field of tractors, Xue Zhifei was honored with the title of National Model Worker in 2020. The honor is one of the highest granted by the Chinese government to outstanding people who have made remarkable contributions to the country's economic and social progress. Now in his 50s, Xue Zhifei continues to work on the front lines of tractor research and development, dedicating himself to the cause of tractor innovation.
When I first started working, I participated in the development of indigenous tractors. Looking back at how far we've come today, I truly feel that we have accomplished a great deal, and I am very proud of it. At the same time, we must continue to develop agricultural machinery products that meet the needs of China's agricultural production and keep making breakthroughs in key technological areas of agricultural machinery. These are the directions where we need to further focus our efforts.
进一步去努力的一个方向。
With that, we conclude this edition of Footprints. Thanks for listening. I'm Bob Jones. If you're interested in hearing more about the lives of ordinary but incredible people in China, follow us on your favorite podcast platforms. Just key in Footprints and you can find more stories anytime, anywhere. We'll see you next time. Bye for now.